Hello, my class 10 students. This is the solution to the test on circles class 10 ICSE, and we are looking at question 1. The test questions were already put up and the link will be somewhere here, so you can refer to that in order to see the questions. So let us begin with the first one. We have to find angle CBA and CQB. Okay, so now in order to solve this, we are going to look at the fact that your AB is the diameter. So you will have this angle will be 90 degrees, and then in this triangle, we will have this angle will be 90 minus 34, which will be 56 degrees. All right, this one and these two angles are linked because for this triangle we are having this 56 as the exterior angle, and this angle is going to be equal to this angle, which I'm going to show with a double ring, and this one also. This is your alternate segment theorem, and then we'll find our CQB. So let us see how we start writing the steps. So our statement number 1 is angle ACB is equal to 90 degrees, since angle in semicircle equals 90 degrees. Statement number 2, angle CBA is going to be equal to 180 degrees minus this angle plus this angle. So we will say angle ACB plus angle BAC, and this will be because angles of triangle ABC are supplementary, which is going to give us 180 degrees minus ACB is 90 degrees plus 34 degrees, which will give us 90 minus 34, so that will be 56 degrees. Now CBA was the first answer they have asked, so this becomes our answer 1. The third statement will be this one equal to this one. So we will say angle BCQ is equal to angle CAB here, which is 34 degrees, and this will be because of alternate segment theorem. So we'll have this angle as 34. Now we will connect angle CBA as the exterior angle. So fourth statement will be angle CBA is equal to angle this one plus this one, that is BCQ, plus angle BQC, and this will be because exterior angle of a triangle equals sum of interior opposite angles. So we will have 56 degrees equal to BCQ is 34 degrees plus CQB, and this will be from statement 2 and 3. So therefore angle CQB will be equal to 56 degrees minus 34 degrees, which will be equal to 22 degrees, and this is our answer 2. Now this question is for 3 marks. So our first mark will be to get this 56 degrees using the angle sum property of triangle ABC. Yes. Then the second mark will be for this alternate segment theorem. And the third mark will be when you use the exterior angle of this triangle equal to sum of interior angles, and that will be your third mark. So if you've written this all right, you can give yourself full 3 marks. So this is comprising of your 3 marks. Okay, let us move to the second question. In our question number 2, we are having O is the center of the circle and your tangents at B and D intersect at point P. AB is parallel to CD and angle ABC is 55. So this ABC is given as 55. we have to find angle BOD and BPD, which are marked as A and B. So this basically gives us clarity of thought. Now let us come to our solution. Now if AB is parallel to CD, that is what is given. So our statement 1 will say that our AB and CD, they are parallel, and we will say that is given. Statement number 2, therefore these two angles will be alternate interior angles. So this also will be 55 degrees. So we will say angle BCD is equal to angle ABC, which is equal to 55 degrees, and this is because of statement 1 and alternate angles are equal. Statement number 3, we are going to connect this 55 with this one because both of these angles are made by this arc over here. So angle at the center is angle BOD, and that is going to be twice angle subtended at the circumference, which is angle BCD, and this will be because angle at center is twice angle at circumference, so that will be 2 into 55 degrees, which is 110 degrees, and this is our answer 1. Okay, now we have to focus on B and we have to connect it with this 110. We have to find this angle, so you will see in this quadrilateral OBPD, you will see that this is 90 degrees because B has this BP as a tangent. So tangent and the radius at the point of contact, they are perpendicular. Same thing happens here. OD will be perpendicular to PD. So we will write number 4 statement that OB is perpendicular to BP, and 5th statement will be OD perpendicular to DP, and this will be because the radius at point of contact is perpendicular to the tangent. Alright, the same reason we will write here, that radius at the point of contact. Okay, you can write that on your own. 6th one, in quadrilateral OBPD, we will have angle OBP plus angle BPD, this one, plus angle ODP plus this one, which is BOD, equals to 360 degrees, and this is because angles of any quadrilateral add up to 360 degrees. Okay, so OBP is 90 degrees here, plus BPD, we do not know, we have to find it, plus OBP plus ODP, which is again 90 degrees, and plus BOD, which is 110 degrees. That is equal to 360 degrees, and the reason for this is 90 degrees and 90 degrees is statement 4 and 5. 110 is statement 3. Okay, so we will have angle BPD will be equal to, this is 180 on that side, so 360 minus 180 minus 110. So it will be 360 minus 180 minus 110. So it's easier for us to subtract 180 degrees minus 110 degrees, which is equal to 70 degrees. So that is your answer 2. Now for the marks, this is for 3 marks. So you are going to have 1 mark for getting this 110. Okay. The second mark will be for writing this 90 degrees, and to get these 90 degrees and the quadrilateral, this one and this one, will give you that 1 mark, and the subtraction to get this 70 degrees, that will be our 1 mark. So that is how we will get 3 marks of this. So remember, the statements are important, the reasons are also important. Any one of the reasons are not given, your teacher can cut your marks. So just be careful. Okay. We now come to the third question of this short test. This should take you any time between 15 minutes to 20 minutes in order to solve this. If you complete this in 15 minutes, it's well and good. So let us see what all this entails. We have PQ equal to QR. So we'll have PQ equal to QR. Angle RQP. RQP. This one is given as 68 degrees. PC and CQ are the tangents, which means these two will be tangents from external point C. They are going to be equal. And we have to find the values of QOP angle. QOP is this, I'll call this as angle A. And QCP. QCP, this is going to be your angle B. So let us see how we solve this. In the beginning, let us just look at this triangle over here. This one. In this triangle, we will see this is 68 and PQ and AQ, they are equal. So we are going to have this angle over here equal to this angle, which I will show with a double ring here and a double ring here. Alright. So if this is 68, we will call this one as X and this one also as X. So 68 plus 2x is equal to 180 degrees. So our first statement we will write as PQ equal to AQ, and this is given. Statement number 2, therefore opposite PQ will be PAQ will be equal to opposite AQ will be APQ, and that will be X, and this will be from statement 1. Since angles opposite equal sides are equal in triangle APQ. Statement number 3. In triangle APQ, we will have 68 degrees plus x will be equal to 180 degrees, and reason for that is angles of triangle are supplementary. That will give us, therefore 2x will be equal to 180 degrees minus 68 degrees. 60 gone so 120 and 8 gone so 112. So x will be equal to 112 divided by 2, which is equal to 56 degrees. So we are having this angle over here, x is equal to 56 degrees. Now this will have to connect with this one here. Okay, so we are going to say statement number 4, angle QOP is going to be twice angle QRP, and this will be angle at center is equal to twice angle at circumference. So that will be 2 into 56 degrees, which is 112 degrees. This is going to be our answer 1. Statement number 5. Now that we got this A as 112, this 112 will be connected with this B. For that we will see PC is the tangent and PO is the radius at the point of contact. So this angle is going to be 90 degrees. Same way OQ is perpendicular to this tangent QC. So we are going to say OP is perpendicular to PC, and statement number 6, OQ is perpendicular to QC. And here for both of these we'll say radii at point of contact are perpendicular to the tangents. So statement number 7, therefore in quadrilateral OPCQ. We will have angle POQ plus angle OPC plus angle PCQ plus angle CQP equal to 360 degrees, and this is because angles of quad add up to 360 degrees. How much is POQ? That is 112 degrees plus OPC is 90 degrees plus PCQ we do not know plus CQP, that's again 90 degrees, is equal to 360 degrees, and here it will be from statement 4, 5 and 6. So we will have angle PCQ will be equal to this 90 and this 90 gives you 180, which goes that side. So it will be 180 degrees minus this 112. So therefore they have given you QCP. So we'll write as angle QCP is equal to 68, and that is our answer 2. This question was for 4 marks. So to get these two x and then to find this x is 56, that is your 1 mark. Connecting that with this along with the reason is your 1 mark. So if you do not write the reason, don't expect the mark there. Then the quadrilateral having 360 degrees as the sum, that and this 90 and 90 substituted from these two statements, that will be your 1 mark, and the last statement to get our QCP, that is our 1 mark. So this question will give you 4 marks. Now you total up and say whether you have got 10 on 10. If you got 10 on 10, give yourself a star. Okay, now this is the way in which you have to solve the question. This was a short test. This is a revision test. Okay, so I hope you have understood how to present your work. I hope you have got your full marks. If not, then practice these questions. Prepare well for your semester 2 exams also, and also focus on all the circle theorems and understand each one well, because circles is an important topic. It occupies maximum marks in your examinations. Okay, so I'll end this video over here. I hope you are taking care of yourself. Stay safe, stay healthy, and bye.